So in today's lesson, I want to talk about probability and Venn diagrams. So to start off, I have a deck of cards here, and you're just going to have to take my word for it that they're already shuffled. So what we're going to do is just draw one, and it doesn't really matter which one we draw, so I'll just pick one here from the middle. There we go. And oh, big money, ace of diamonds. So let's go ahead and set that here. Now, what we're going to do is look at the probability of us having drawn the ace of diamonds. So first I want to review with us for just a moment the definition of probability. This one you probably either learned in school, your teacher taught you, or you read about it, or you figured it out on your own. But I'm going to say the probability of some event X occurring is equal to the number of desired outcomes divided by the number of possible or total outcomes. So in our case, there was only one outcome. We got the ace of diamonds, but I promise you it was a full deck, and so there was a total of 52 possible cards that we could have chosen. So this is a classic definition and is going to serve us very well for determining the probability of some event. Now, it's always important to remember that the probability of X always has to be greater than or equal to 0 and less than or equal to 1. So we can't have negative probabilities, and we can't have probabilities greater than 1. And 1/52 definitely falls within that range of values. Now what we'd like to do is go ahead and take a look at Venn diagrams. So I'm going to add to this just a little bit. I'm going to start with just A being the event of drawing, in fact I should write the event of drawing, let's say, an ace. And I'm going to call B the event of drawing a diamond. So these are the events themselves. So what I think I'd like to do now is go ahead and scoot this up a little and take a look at what our Venn diagram might actually look like. So to do that, I'm going to need a couple of circles and probably a box around some things. So let's go ahead and do that. I have a handy dandy little circle maker here. Draw the center there. And let's just move this over to there. Another circle. Okay. And now I can put a box around these if I'd like. So there we go. And this is probably what you've seen as a Venn diagram representation of probability before. So over here on the left, outside the left circle, I'm just going to write the letter A to represent the event of drawing an ace. And on my other circle, I'm going to write a B, and that's going to stand for the event of drawing a diamond. Now, I already know this intersection in here. The probability of drawing the ace of diamonds is 1 out of 52. So I'm just going to go ahead and write that in there. So I'd now like to find the probabilities for the rest of B. So what's the event of drawing a diamond? I need to know the probability of B. Well, how many diamonds do I have? I think I have 13 out of 52, as long as I have a standard deck. So if I already have 1 out of 52 here, then that means I'm going to have another 12 out of 52 in this region, so that those 12 cards are not the ace of diamonds, they're the 2 through king. And then I need the probability of A equaling the event of drawing an ace. Well, that's 4 out of 52, or 1 out of 13. And if I have 1 out of 52 already, then that means there's 3 other aces out of the 52. Now I do need to make a slight correction because even though I labeled this B, I've now written in probability. So I need to write this as the probability of B and the probability of A. So I noticed that there's 12, 13, 14, 15, 16 out of 52. So that's going to give us 36 out of 52 on the outside of this. This is just everything else that's possible, and we're not going to worry about that for the time being. But there is a representation of the Venn diagram, which shows the probability of drawing an ace or a diamond, or in this case, the ace of diamonds. I want to show one more little bit of notation that's kind of important. And so if I want to show the probability of drawing the ace of diamonds, that's A intersect B. And that is our overlap region, which in this case is 1 out of 52. But you can see if I was to shade this, this would be my overlap or my intersection. And you can remember that because this little thing kind of looks like an N. All right, so I think we'll leave off there for today.